So series circuit this one E R sub 1, R sub 2, and R sub 3. Okay, for example, 10 volt, 2 ohm, 3 ohm, and 5 ohm here. Okay, for this case, here, R sub T, the total resistor, R sub 1 plus R sub 2 plus R sub 3 means 2 ohm, 3 ohm, and 5 ohm. Okay, the panel. And the I sub T here, I sub R sub 1 and I sub R sub 2, I sub R sub 3, I sub T, I sub R sub 1, I sub R sub 2, I sub R sub 3. For the DC series circuit, okay, it's very important. That was E divided the R sub T. Okay, 10 volt divided 10 ohm, 1 amp. Okay, this is the total current. Keep in mind, one more time, in the DC series circuit here, they have sub R sub 1, I sub R sub 2 should be the same. They can calculate it by using Ohm's law, like this one. Okay, see here, see. V sub R sub 1 is I sub R sub 1 multiply R here. Okay, here. This one. So the I sub R sub 1 here, the R sub 1 means 1 ampere times R sub 1 is 2 ohm, is 2 voltage. Okay. And D here, V sub R sub 2, I sub R sub 2 times R sub 2. That was 1 amp multiply R sub 2 is like 3 ohm here, right? So right there, 3 ohm, 3 voltage. And E, V sub R sub 3, I sub R sub 3 times R sub 3. Keep in mind, different the R sub 1. So that was 1 amp multiply 5 ohm, 5 voltage. So here, in the DC, 2 volt, 3 volt, 5 volt. So it means supply voltage E is V sub R sub 1 plus V sub R sub 2, V sub R sub 3. So supply voltage is the equal to voltage drop for each resistor in the DC circuit. Okay. So from here, we're gonna see that two things right there. Okay. Series. Okay. So how about the pedal circuit? For example, I sub 1, I sub 2, and I sub 3. For example, there's a 10 volt, 5 ohm, 2 ohm, well, 1 ohm here. Okay, so now, in the pedal circuit, what is for total resistor? Okay, here. What is the total resistor? So can you see that right there? That was in series, right? So R sub 1 pedal, R sub 2 plus R sub 3. So R sub 1 pedal, R sub 1 is 5 ohm, and that was 2 plus 1, 5 ohm pedal, 3 ohm here. So now we learned before, the formula, 2 resistor, A plus B over A times B. Okay. So 5 plus 3, 5 multiply 3 here. 15 over 8. So that was 15 divided 8, 1.9, 1.9 the ohm here, okay? 1.9 ohm here. Okay, so what is the total current? The total current, E divided the R sub T. Go back to the circuit here. That was I sub T, right? So I sub T is 10 volt divided 1.9. Oops, I'm sorry, 1.9 ohm here. Finally, 5.3 amp here, okay, by using calculator. Now, go back to the circuit. Okay, so now here, writing here. So what is V sub R sub 1? V sub R sub 1, well, from here, we have to know in this circuit that between the two components, they have no, maybe any components here that should be same. I'm going to show you this the another color. That should be the 10 volt. That should be the 10 volt here. Okay, so means V sub R sub 1, the 10 voltage, and I sub R sub 1 is V sub R sub 1 divided the R sub 1, 10 volt, that divided the 5 ohm here. This is the 2 amp, right? So here, I sub R sub 1, I sub R sub 2, put the I sub R sub 1 here, the 2 amp, okay? So we learned before KCL, I sub T is I sub R sub 1 plus I sub R sub 2, or I sub R sub 1 plus I sub R sub 3. Why? Because they are in the serial between the register, okay? So now we learned before I sub R sub 1 here, right? So I sub T minus I sub R sub 1, I sub R sub 2 is what? Go back to I sub T, 5.3 amp, 5.3 amp minus 2 amp, 3.3 amp here, okay? 3.3 amp here. It's very important. So this is the I sub R sub 2, okay? This is I sub R sub 2. Now, from here, I'm gonna change voltage here. So from here, also we're gonna say V sub R sub 2 plus V sub R sub 3, the 10 voltage. And then the I sub R sub 2, I sub R sub 3 is what? 3.3 amp. It goes right there. Okay. So now V sub R sub 2 is I sub R sub 2 times R sub 2. That was what? That was 2 ohm multiply I sub R sub 2, 3.3 amp. So that was 6.6 voltage. Now, here, V sub R sub 2, 6.6 voltage. V sub R sub 3, 10 volt minus 6.6 voltage. Okay, let's find a 3.4 volt. That is the answer. Okay. All right. Okay. So keep in mind, one more time, the pedal circuit, same voltage, the 10 voltage. Okay. And but in the KCL rule, so I sub T is I sub R sub 1, I sub R sub 2. Split up. Okay. That is what we needed to do. Okay. Thank you.